All right. Well, thank you very much for your time. Thank you very much for attending this presentation. My name is Marco Schejtman. I work for NetFoundry. Basically, today I'm going to talk to you about how to access to your databases in a secure way using OpenZiti, right? So let's start discussing about it. This is Iggy. This Iggy is our mascot, right? But this is my description, right? I don't have like a good photo, so I think Siggy looks better than me. I have over 15 years experience working, especially in cybersecurity space, a little bit on infrastructure. Actually, I started my work journey working for a bus company in Mexico in a network space, right? All that kind of stuff, handling VPNs and all that kind of things, funny things, right? That happens. I'm a little bit paranoid because I know what I can do, so I think I can know what everybody can do to me, so I'm a little bit paranoid about it. I'm a video game amateur player, right? I'm not good at it. Even when I play like a couple hours daily, I'm not good at it, so yeah. And most likely, or ultimately, I've been working on cybersecurity space, especially as an evangelist on different topics. Most of the topics that I'm most passionate about, it's open source, obviously, zero trust, SOC building, all that kind of security operation centers, and because I performed some pen testing to SCADA and OT infrastructure time ago on my other lives, well, I love to get involved into the OT infrastructures as well, to helping companies to protect all those kind of stuff. So who cares about this conference I'm going to provide? Well, especially we're going to start with developers and architects, right? As a developer, I know the pain. I've been developer since a very long time as well. As an architect, I know it, especially right now when everybody's talking about digital transformation, where your data can be anywhere in the space. Well, it's getting complicated, right, for us to get access to. Also, when you have to handle other VPNs or you have to handle other systems to belonging to different customers, belonging to different clouds, etc. Well, it's kind of hard. It's getting complicated, right? So that's the things that people normally don't see. Everybody talk about how beauty cloud is, but we forgot sometimes that kind of stuff. Security experts, that's the other ones. It's zero trust. It's obviously security. So as a security, you are getting involved into this. And of course, the new DevOps, NetOps, DevSecOps, etc. Right? So this new trending in employees and how everybody is talking about getting automation, agility, stuff like that. However, even when everything is it's beauty, the future it's a little bit scary, right? We have multiple breaches, and each breach is getting more and more expensive, right? So it's a good thing for attackers. It's a bad thing for us, right? So that's the thing. Also, well, we know there is multiple 0 days occurring all the time, right? We just knew about this UC Live. We just get the Spring4Shell, the Log4j, etc., etc., etc. So basically, we are filling up with 0 days that is happening time to time everywhere, right? So we kind of getting crazy. And that's not the only thing, right? You can think about security because that's my passionate feeling and stuff. But the thing is that security is not the only thing. The business is also all the time, right? So while we as a security department, we're trying to pull everything, right, to try to protect the company, the business needs to move, right? Because you can create something really secure, disconnected from the network, but it's not going to work for the business, right? So we're going to have issues. So we have this thing as well. And finally, well, when we have to handle all those kind of stuff, we always know what is the business, right? It's, well, install a VPN, install it, and you're ready to go. A problem is when it's just one VPN, everything's good. But when you're getting with the VPN from one provider and then another vendor and then another vendor and then another vendor, and then you have like IP collisions and everything, and nothing works, right? So that's the other thing that always happens time to time, because essentially every single company handles the VPN to their own access in the way they want to work, right? Because, that's how it works. So In that Foundry, we created a new open source project called OpenZiti. OpenZiti is trying to help all this kind of business, right? So essentially, we're going to get started with this classic network. And this is the model that we already know. This is the model that is working everywhere, right? So basically, you have access. Right now, everything is interconnected, right? My watch is already connected to the internet. My fridge, basically everything right now, it's already connected to the internet. Everything has access to everything, the cars, whatever. But at the same time, well, it's not only us who has access to it, right? Or attackers also have access. So that means that even when we try to protect our assets inside our castle, there is always one attacker that is going to be able to reach that castle because he knows where or whom he is going to attack in order to access there, right? So that's one of the biggest issues. So what can we do? Well, in first place, we need to recognize that the perimeter has evolved, right? And actually, there is no more perimeter, right? Let's be honest. I don't know about you, but right now, for example, during this conference, I have to be doing some work as well. And I'm working from here. So basically, my company cannot protect me, right, in an easy way. Customers, what I need to access to, cannot protect me in an easy way. And sometimes even, right, especially with these pandemics, when the pandemics started and everything, people working from anywhere, right? It is not more working from home, it's working from anywhere, right? I know a couple of my friends that actually went to the beach. They moved to the beach when the pandemic started and start working from there, right? So basically, we need to understand that the perimeter has been changed, right? We can no longer protect everything. Originally, it was quite easy. We can just put a firewall, an IDS, an IPS, and everything, all that kind of stuff, and then we can start protecting, right? Because normally, everybody was working on the same space, but right now, that doesn't apply. And right now, we have to recognize that the perimeter is not longer where it used to be, but it's on the application side. The application is the new perimeter. It's not us, it's the application we are dealing with, we are working with. So what can we do about it? How is this OpenZiti concept was handled? Well, let's get started with the beginning, right? We don't know, right now we know that everything connects to the internet. So basically everyone who can connect in there can visualize or try to attack anything that is already connected in there. So what we thought was, okay, we can create like an overlay network in front of the internet, right? If we do that, basically what we are going to do is that we can create different networks, kind of like a VPN, but in a secure way. Instead of providing access to the full network, we're going to start providing access to the services, protocols, applications that need the current access. We are going to provide that. And how we are going to provide it? Well, the first step is with something we call the controller. The controller is the main piece, and this piece is going to provide us access in order to authenticate our users or our identities. It's going to provide the access to also authenticate every single identity that is working inside the network. We're going to talk about more in a few. And of course, it's going to provide us the access to handle those policies we want to handle with the information. I mean, how we can connect to every single port. Do I have the permission to connect or not? Do I need to do something else or not? And you can start adding more other things, like, for example, fashion or fancy stuff like review versions of your platform, of your operating system in order to see if you can connect, versions, drivers, etc., right? So you don't access anyone who can have, like, for example, insecure versions on, I don't know, any application or something like it. Then, from the controller, we're going to create something that we call the routers. The routers are going to be divided in two. Basically, we're going to have the public edge router. This is where you are going to reach. Essentially, right, the idea is not open any inbound ports, but allow communication to external. So basically, we're going to put these edge routers that are more likely like publics. Let me try to, there we go. So basically, those are like the public's routers, right? So when you need to connect, you are going to connect over there. But the funny things and the beauty of this is that those routers cannot actually reach anything outside their scope. What it means is, let's assume that an attacker can hijack that edge router. Well, that edge router doesn't have access to anything, right, outside the tunnel we are building. And then, of course, after we're doing all this, we have something that is called the full mesh. The full mesh is going to provide us the access and the fastest path to achieve our goal, to be enabled to access to anything that is on the other side. So that means that basically we're going to be able to protect everything. All the communication are completely protected. We are using a mutual TLS between the communication on every single edge at the same time while using Cha-Cha internally in order to protect the communication so nobody can, start spying whatever is happening over there. And finally, this is going to allow us to basically have any client connecting to any application in a secure way, right? So that means that we are going to find the fastest path according to all the routers that we have installed into the platform, and with that, we are going to be able to achieve our goal and basically reach any service or anything that is happening on the other side. And the beauty of this is not listen ports, right? So this is going to provide us a few advantages. How many of you have heard of port knocking? Port knocking? Yeah, have you ever heard about port knocking? Port knocking. Port knocking, yeah. So it is cool, right? It is an old concept. I used to use it long time ago, right? Well, not long that time. Yeah, not that long, but still, right? And it's a nice thing. It's, everything is closed, and then you go to the firewall and say, okay, I'm going to touch the port 80, then the 443, and then the, 62. And then, by magic, the port SSH, the 22, is going to open, so you can access once to that port, and then the port is closed again, right? It's only open for your IP. The thing is, for example, back in Mexico, we also use this NAT behind a NAT behind a NAT, right? Because there's not many IP, public IPs. So the issue is that when you open up the port for you, basically you are opening up that port for many other people, right? So what we're doing here is avoid that. The other thing we're going to get is we're going to be able to have more time against incidents, especially against 0 days. And we're going to talk about more lately. So when we're talking about all this overlay network, there is something else that is going to appear in our mind. And it's, well, how many options we have to perform zero trust. And that's the way we created like this kind of methodology or acronyms that we can use to start to talk about zero trust, how it works, etc. So the first one we're going to talk is zero trust network access. Basically, this is like normal VPNs. You are providing access to one router to the other router, and basically everything that is living in here is going to be able to reach everything that lives on the other side, right? So that's the first thing. That's the first way you can do it, and it works. However, there is other ways we can start working at, right? Because essentially when you do that, you are going to allow that everything can pass through, right? Like for example, if you are working from home, every single device that you have in home can access to the other assets that you may have on the other side of the network. So basically, we can change that and provide something else that is called the city host access. In this particular case, what we are doing is reducing the surface of attack to the host to host. So basically, we have one host running here. We have one host exposing some services internally or locally here. And what you're going to be able to do is connect from one application or to the other application. So you only trust on the machine you are currently using. And that's good. We just reduce the attack once again, right? Because right now we are not longer having or providing this access to everything that is happening or to anything that may happen in there. But we can be beyond that. We can provide something else that is called the application access, right? And the application access means that essentially you can embed the SDK of the Zero Trust directly into the application. So that means that if, for example, you may have any kind of client, database client, connecting to a database without need of any agent, any VPN, or whatever. So that means that if an attacker tries to connect into the machine and then from the machine try to launch a PowerShell or something like it to try to exploit anything that may happen on the other side, it's not gonna be possible because the only thing that has access to it is the application by itself. This JDBC driver, or could be the client database, etc., 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 right? All right. So what kind of superpowers can we get using OpenZiti? Or what kind of things can we do using OpenZiti? Well, the first thing is define your network, right? We currently know that every single protocol normally has its own protocol number or its own port, right? You access to the SSH via the port 22, you access to HTTP via the 80, you access to your email via the 25, etc., 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 right? So basically, you already know all those defined ports. Well, with OpenZiti, you can change that. You can provide more access in the way you want to. You can say, okay, I want to communicate with my SSH via the port 443, or I want to access to my SQL database via a port 80, or I want to access anything. So you have the ability to start redefining the network in the way you want. So that provides an extra layer of security because it's essentially security by darkness, right? So you are darkening that access in the way you want to access or the way you want to provide it. The second one is addressability, your own private DNS, right? So no more multiple IPs where you may have the ability or you may have this issue to have IP escalations, especially when we're working with many customers, right? That's an issue, right? That happened to me a long time ago when somebody provided me one vendor VPN and the other provided me a different vendor VPN, and then I launched both and I received the same address, right? Quite the same address on the same space, because to be honest, we are not quite creative creating those VPN access, right? It's always the same. It's the red 10 or the red 172 or the red 192, but essentially we always use the same, right? 192.168.0.1 or 100.1, stuff like that. So basically everybody is doing the same, so we have multiple collisions, so it's quite complicated. From here, you can create your own DNS. You can say, okay, I want to connect from Marcos or Clint's computer to the service or the application I want, right? So it could be Jenkins, could be customer 1, database 2, etc. Customer 1, MySQL, customer 1, Oracle, customer 1, whatever. Basically, you have the option to connect to whatever you want using the names you want for that. And it's a private DNS, it's not going to be replicated, and it's only living in the scope of the Zero Trust application you're using. If it's the whole network, well, the router is going to have the access. If it's only your host, the host is going to meet or know everything that's happening. And finally, if it's the application will know everything that is happening in there, okay? Second one is app-embedded client-side. And this is something really nice. We're going to see a couple examples of how it handles, how it works, essentially. But what is going to happen in here is that you can actually embed our software OpenZiti directly into the application, and the application is going to be able to talk to whatever he wants. We have some demos, like for example, adding this JDBC wrapper inside a web application server, right? Tomcat, JBoss, WebLogic, whatever, accessing a database living in a cloud without any kind of VPN server or something, because you are actually adding the client side, on the client side, right? In this particular case, the application service being a client of the database, of course. But it's not the only thing we can do, right? You can also do app embedded on the server side. And that means that you can actually expose only those ports or only those things to the services or to the clients or to the identities that can have access to it directly. Like for example, FTP, SSH, whatever. Even a web application can have that. And that means that the port is not going to be publicly exposed. Only people or only the identities that live in the same network and has or have the ability to connect to it are going to be able to reach it out, okay? Finally, obviously, no listening ports, because we are actually closing everything, and that's one of the beauties. You are not going to expose any port. You are not going to expose anything inside that, right? So how it works? Well, I told you, right? I don't know how many of you remember what just happened with the Log4j last year and what happened with the Spring4Shell probably a month ago or something like it, right? people got crazy, right? I was there. I saw that. I know many companies in the region, in Latin America, that they got mad. They got crazy because they had to patch, right? And what is the problem of patching, an exposed server or exposed application like that? Well, let's remember what happened with the Log4j, for example, right? It was the first patch. Everybody say, well, it's done. There is no longer an RCE. We're due. However, that version has a DDoS problem, right? So essentially, if you patch with that version, anyone could launch an attack, a simple attack, and perform a DOS attack into the server. So basically, it's like, okay, so nobody is going to steal you anything, but still, you cannot work because your service is going to be down. Then they release a different patch. It has a different vulnerability until they finally release a stable one, right? So that took probably a week to get everything done. And that means that companies had to patch around 2 or 3 times, right? So it's complicated. It's hard. It's difficult. And in security, we have something that is called the timing, right? If you took more time to respond to any attack, well, consequences could be large, right? So what we can provide in here, well, basically what we can do is our attacker can try to get into there, but using OpenZiti is going to be impossible for him or for her to attack basically the server that may happening in there, right? And the reason behind that is that only those servers, only those identities that may have the ability to connect are going to be able to reach the service or the server we want to, right? And that is going to allow us not only to remain on patch, because that's not something I'm going to recommend, right? But it's going to provide us with a different thing, and it's reduce the surface of attack, right? If we reduce it, we are going to have more time, because instead of having multiple hackers, multiple script kiddies, right, trying to reach out your server and provide you with a, I don't know, something, you only know that you are going to have those who you originally trust, right? Your employees, your customers, even your partners maybe, right? So basically the surface of attack has been reduced dramatically, so you have more time to test the patches before release them into production, right? And that happens not only for Log4j, for Spring, for whatever that might be running in there, right? So you have time to basically avoid all that is happening in there, right? So let's see how we can get these superpowers, right, with Ziti, how we can do it, what we can do, how we work, etc. So the first place we're going to discuss is how we can use it. Like I said, you can use it directly into a client or user side, right? Like for example, in a few, you're going to see that I have already installed a client into my computer to access to different services that my company provide me, but also because I'm quite paranoid, that I already provide to my own, right? So I do have multiple services in the cloud, even right when I need to travel, like right now, I told you I'm an amateur video game player, but this thing doesn't run any good game, right? So when I want to play, I just connect to my computer in my own place, on my own rig, and I can play from there. The other way you can use is on the user side, as we discussed, what is called on the server side as well. And of course, basically, you can use it on anything that may happen, because we already have this SDK that can work internally on everything. Actually, for example, we have integrated the SDK into the OpenWRT. So basically, you can create your own router connecting to anything you want, right? If you trust enough into your own computer or your own home network to do it, right? And of course, it's already available to be run on any major cloud that it's already running in here, right? So, and when I say major cloud, I'm talking about, I think we have support for over 8 of those cloud providers right now. So basically, it's a big support that we already have. And you can deploy the software basically anywhere, anytime, right? What do we have on SDKs? Well, basically, you may have the SDK for C, right? You have it for .NET. You have it for Java as well, for Go, for Swift, if you want to build application mobile on iOS. Also, the Java one has the mobile Java, so that means that also works for Android. And of course, Node.js and Python that is been releasing in a few, right? So how this stuff works, what is this app embedded zero trust, how it works? So basically we're going to see a couple examples in here. I even, I'm going to perform a live demo. People say live demos are not good, but let's take a risk. So how it works essentially is you basically download the code and embed it into any open source project, right? Or onto any private project if that's the case as well. Our license is Apache 2.0. So basically, like for example, in this particular case, we have certify or make zero trust Prometheus. That means the Prometheus can actually connect to any database in a secure way to grab the information it needs without anything open up, right? And the use of the SDK, it's quite simple. Most people may think that it could be a full mesh or it could be a full mess to do it, but no, it's a couple lines. You can see, like for example, this particular case, it's quite simple, right? But what we are doing here is saying, hey, I want to bind this application server in this particular port, and that's it, right? So essentially what is going to happen is that it's going to be listening for any petition or any request that we can get. After Ziti, as you can see that basically the first thing we've done is initialize the tunneling, right? Or getting to the identity. Basically what it does is going to connect directly into the Ziti network. And posterior or after that, we are going to say, okay, right now I want to host this service. And this is the beauty, because as you can see, we are not providing any port, we are not providing any IP, we are not providing any kind of information. We are only providing information about the name of the service we are going to host. In this particular case, is super secure service. And that means that during the phase of management that we are going to see in a bit, we can remove that. We can actually create that service is going to listen on a different port. It doesn't matter. At the end of the day, we can change that on real time and directly and easy like that, right? What is going to provide all this information? Well, in first place, like I've been saying all this time, at security, right? That's the first thing. Yes? On this particular case, as you can see, is server side, right? Yeah. Yeah, in this case, it's server side. Well, client side could be exactly the same, right? Instead of using the bind, you can just say connect to. Yeah. Yeah, yeah. It's like, yeah, in here is like this, right? So, yeah. Secondly, we're going to get best performance, right? So it's going to allow us to create multiple things, to be faster. Also, as everything, it's OpenZiti is a platform created by developers for developers as well, right? So that means that everything is SDK enabled, everything is API enabled, so you can also have performance, you can create anything you want, and you have the best experience of all, right? So how we can do it? Let's see a few examples. In this particular case, I'm going to show you two. The first one is using our first release that is called the JDBC. JDBC, basically, it's a wrapper of the JDBC libraries that allow us to connect securely to any database. We are not inventing a full JDBC wrapper. We are using actually your current drivers. That means you can use the driver from Oracle, you can use the driver for MySQL, the driver from Postgres, from everything, right? And we're just a wrapper inside. So in this particular case, let me clean this up. I don't know why that can clean up. Anyway, in this particular case, we are trying to use, this probably makes familiar, it's an application server, right? And we are telling it, we are going to connect using this driver. As you can see, the driver is Ziti driver, right? This is the only difference in there. This is the URL. You can see that basically that's the URL to connect to an Oracle database. And the only difference that actually happening here is this particular start. Instead of starting the URL with JDBC, we are using JDBC in there. So the driver gets the request, see that there is a C in there, and then it looks for what is the actual driver he needs to call. And he'd say, okay, it's Oracle. So he delegates the communication then to the Oracle driver. That means that, everything that's already built into the driver is going to work. For the case of Oracle, all that kind of stuff with rack databases, and all kind of stuff is going to be there, right, easily. Same things as for Postgres, MySQL, etc., 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 right? And finally, we have a couple properties, right? In this particular case, obviously, is the user. But finally, we are using an identity file. This identity file, for simplicity, I'm using just the JSON. However, important, like everything in Java, for example, could be using the key store, right? So if you're using another different kind of application server, you just put it into the key store. The key store can be loaded for the application, and it's going to be ready for the solution as well. But this not only works on server side, like I told you, this also works on clients. So basically, this example, I like this example because it's going to show you a couple things. The first one is, this is a connection using a client database to an autonomous database in the Oracle Cloud, right? And you can see it's exactly the same. The only thing I changed was the start of the URL connection. Instead of being JDBC, we're using CDBC. And that's it. Basically, anything else is the same. The driver, right, we're using Oracle with City because that's the name internally into the wrapper, but essentially it's going to delegate, right? We didn't recreate the Oracle's driver or the MySQL driver. It's just a wrapper in there. And in here, this is a connection to Postgres, right? Same thing, right? You can see the only thing is going to change is the beginning of the word, right? It's starting with CDBC and then providing and delegating the access. Funny thing about this, this is an access from one of my colleagues' computers connecting to my own Postgres database in my own place, right? I live in Mexico, he lives in the US, so no VPNs, nothing like that. It's just directly, and actually, he only can connect to my database in this particular case, right? Using the CDBC driver. So that's the beauty of how it works, right? So let's do a small demo so you can see how easily you can provide access, how easily it works. So let me discard annotations. There we go. Hopefully you can see it. OK. So this is my own personal administration of the platform. I'm using my cell phone to get in, so hopefully it's not going to be that slow. So basically, you can see these are the identities. I have created multiple identities. Each identity can have access to different things, right? So for example, in here, you can see that there is a computer called Alberto's. This is my own computer. This is the one I'm working right now. And they have these other servers, right, distributed across different things, et cetera, et cetera. So what I'm going to do right now is going to show you how to create a policy, how easily it's going to create a policy, and how we can access to that policy to different users or remove that. And it's just with one click, right? Instead of using the normal concept of airbag, we're going to use a different concept that is called RBAC, right? So basically, it's kind of the same, but you know, when you're working with roles, you basically have to define how a role is, right? You need to say, OK, so human resources might be access to this, a developer may be access to this, the DBA may be access, et cetera. You start defining how it works. As more complex are getting the things, it's getting more and more complex and more difficult to handle all that, right? Imagine being a VPN, you need to create a group for something, a group from something else. It's getting crazy. However, using attributes, it's quite more natural for us, especially with the whole new model that we're using after social networks, right? Where everything used to be with attributes, or where we used to write blocks, right? When you use these attributes to look for something, well, it's kind of the same. So what we're going to see here is, you can see here, I have this Hermes MariaDB. This is an already created policy that I have in here. What I'm telling you, or what I'm telling the platform is, I want to connect to this database using the name Hermes.MariaDB and the port 443, okay? Internally, this is going to redirect it to the current application that is working, and is going to send the petition or the request internally to the port to the local host and the port 3306, okay? Let me remove, yep, there we go. So, and of course, there is a couple things, I'm sorry, that escape didn't happen, okay? There's a couple things as well. here we have the role attributes. In here, we can define what is this thing is doing, right? So I can say this is the MariaDB admin. It's living on the Hermes database. But I can also say, you know, this is going to provide us course, I don't know, probably SSH, DB. I don't know. You can start creating different attributes in the way you want to work with it, right? By the way, I'm showing you the fancy thing, which is the web console. But if you don't like the web console, you can also use the command line, right? It's fully available, and you can also use the API if you want to programming something else. So we have created this thing. Finally, we have the police. In the police, we are going to define who can access what, right? And it's quite easily to do that. So I'm going to look into my MariaDB police. Here it is. There we go. So what I'm doing here is, okay, I want to create a new police. This new police, it's called MariaDB, right? It's from the type of dial. Dial means that I can't actually go into there. You may have two types of policies. You have the dial policy, and you have the bind policy. In the bind policy is who can't actually put the port into listen mode, right? Like, for example, when we saw the example of the server, right, trying to bind it, well, it's exactly that. So in here, I'm telling, okay, I want to connect, or I want to create a policy, and this policy is going to affect every single service that has the attribute called MariaDB admin, right? If I only have one, it's going to be only one. If I had two or three, I can access to as many as one. However, as you can see, I have here my identity to role attributes, and it's set to none. Basically, nobody can access that. So let's try out. This is my Beaver database, client database. I'm going to try to connect to the server. And as you can see, it's screaming that I cannot do that, right? It's telling me that hermes.mariadb is not accessible using the port 443, right? And basically, makes sense because I don't have the access yet. So how can I get the access? Well, in this particular case, I can start assigning those attributes to whoever I want to. Like, for example, I may say I want to, the one who can access to the MariaDB could be those that has the attribute DBA, or who has the attribute DBadmin, right? Any of those identities that may have those attributes can access to the MariaDB application. So we can add it in here. So finally, you can start seeing that it currently making more sense. We are assigning all those attributes. We are assigning these attributes to the services as well. And finally, we can decide, okay, this is my device, and my device has the access to DBadmin. So that means that in theory, right now, we should be able to access their service, right? So let's try once again. We close that out. And then we say, okay, try to connect once again, right? So right now, it's not screaming, right? Didn't launch anything crazy. It's trying to connect right now to the platform right now. And as you can see, I do have access now using exactly the same configuration with this, right? Which is the hermes.mariadb at the port 443, right? And at any time, this is the beauty of this. At any time, you can say, this identity or this service or this application or Marcos in this particular case shouldn't have access to these, right? Because he's no longer a DBadmin. He's right now a senior manager, so he doesn't have to connect to there, right? We're going to remove that access. So we can do that. We save his access in here. And basically, whatever Marcos wants to do from this side is not longer be able to do it, right? So I can see and say view tables. And as you can see, it's trying to load. It's not going to be able to do it because I just cut the service out, right? And you can see that we can create as many things as you want. You can create anything you actually want to perform this kind of stuff, right? So you can move in the place in the way you need it. So questions so far? Yes.
So I see that it's going to from 443 to local. So there's something sitting, some client is running on the database server.
That's a really good question. So If you remember a little bit, I talked there is multiple ways to provide the zero trust access using OpenZiti. You have network access, which is network to network. You have host access, which is essentially what I'm showing right now, which is host to host. But you have also application to application, right? So depending, at the end of the day, zero trust is a journey, right? Everybody wants to do that, like close everything and nobody has access to anything. And it's cool. I mean, I love to see that. But it's tough because the business doesn't want that, right? The business wants agility or something like it. So it's a journey. You can start working in this particular case using agents. The agent can be installed on any host, and you can provide that. Instead of the agents, you can provide, like, for example, I can show you different configurations. You don't want to provide access using an agent. You want to provide it using a router, for example. Well, you also have the ability to do that. You can see in this particular case, there we go. This is services I'm using for threat hunting. And as you can see, in this particular case, I'm providing full access to everything, right? So basically what I'm doing here, it's, I want to provide everything that's running over there, right? So it's redirecting the traffic to a computer. So that's network access. You can also have application access, which is, just application to application, like in the case of the Prometheus service.
So in your example, you were using an agent on the box.
Yes.
And then port 443 was open.
No, nothing is open at this moment. Like, for example, I can show you, essentially. Let me connect into here. I'm going to connect right now to a service called hermes.ssh. Let me see if I can do that, or... Oh, it's connecting. Yeah. There we go. So basically, this is the service, right, where everything is running and stuff like that. I can just turn off in here. You can see that here is my tunnel running inside it, right? So this one is the one that has outbound connection only, right? This is only outbound connections, right? So basically from here, this is making the full tunnel, right? Application to application, tunnel to tunnel, it's, right? Kind of like it. I have two of these running because one of those is running on my own laboratory. The other one is running on the NetFounders laboratory to provide the same, just different things. I'm showing you the open source, but we can also show the SaaS version, right? Yeah.
So you're running so like to get autonomous, right? Which is private IP inside OCI, right? And so, you could go through a VCN or VPN, go through SSH to Bastion or something like that. So where's your stuff running? I mean, I see how the policies work, where it is.
Well, this particular case is this Hermes service is actually a Docker instance that is running on a virtual machine that is running on a virtual machine that is on OCI. So I know it's like crazy stuff just to show you that actually it doesn't have access to anything but internet.
And that established the connection to the agent that is running on the host.
Yes, that's right. The only thing,
So you need to open or agent connect to the
yes, so basically, let me open up this a little bit. There we go. So what you have here, this is Hermes, for example, right? Oh, I forgot to add the pen. There we go. So this is Hermes, and this is Apollo, right? So this is my machine. Apollo is this computer. Hermes is the thing that is living anywhere else, right? So the only thing is you can see is this particular guy needs to have access to this router, and this particular guy needs to have access to this router, right? So those things are the only things that are actually listening something because it's the way you can connect. But this one doesn't need any inbound port. The only thing it needs is the outbound port to this one, right? To communicate to that. Yeah, and normally it lives on the same network or something like it. Yeah. Yes. quite similar. We call it like a mesh, but yeah, essentially it's kind of like a tunneling between all those, right? The difference between the VPN and stuff is this router doesn't have access to any other router, right? But only on the application running. So basically it's a software tunnel that is running, right? So it doesn't create any IP, etc. Like for example, if I want to, let's say in this particular case, I want to SSH to Hermes MariaDB, right? In theory, I should be able to because I can ping it, right? Hermes.maria, oh, I forgot, I delete the property. Let's add it again. Oh, damn it, thank you, yeah. All right, let me close the presentation mode. I just got, I think it's, yeah, let me, oh, okay, let's see. Okay, I think should be ready to show. Nope, PowerPoint just don't wanna work. Let me close that out. There we go, PowerPoint. Okay, I had to close PowerPoint. And I don't know why it's not. All right, so I'm gonna work in here. Excuse me, but I don't know what happened on the computer. Right now is not duplicating the screen. So as I was saying, I'm also going to move this one here. As you can see, if I just ping it, nothing happened, right? Because I delete the policy that allows me to do that. So I can go in here and select my identity once again, which is the DB admin, and assign that attribute once again, right? There we go. So you can see here it is. Edit. Here it is, DB admin. There we go. And I just save it, right? So essentially, this thing is the only thing that should have access, right? Once again, I can try to connect. I can do the ping, and as you can see, it's answering a ping. And this is the IP that is being created by the agent that is living in my computer to create or to perform the activity over there. So from here, I may say, okay, let's try to do an SSH to Maria Hermes.MariaDB, right? And it's not going to be able to do it because essentially nothing happens. It's not possible. I can try using my public edge router, right? You may say, okay, but what happened on the router? The router may have access to it. Well, let's see once again. There we go, -E. You define the different identities based on where you want, and you can distribute those identities to the different users accordingly. Like, for example, could be an application, could be a mobile, right? My mobile, for example, has access to to the Mattermost, which is our communication platform, and they distribute me that client, right, via email. So there's multiple ways you can distribute. So from here, you can see I'm connected in here, and I can try, right, the same, Hermes.MariaDB. Doesn't exist, right? Right. And this is the router, right? If you see, right, this is running my router in here. Yes. Yes, you're reducing the attack vector, right? Because essentially you're no longer providing full input parts, it's only outbound, and you can start defining, well, it's gonna be outbound only to my routers. That's it. I don't need to outbound to internet or whatever, right? It's only to the router to create the communication. And from the router, you don't have the access because the router doesn't have access to the computer, to the other side. Like in this particular case, this one is the router, doesn't have access to Hermes, right? Yes. Yeah, because the router lives on the internet, so it should be exposed to the different clients. Yes. Yes, we're using mutual TLS between the endpoints or between communication between routers and the different identities you can select it. And internally is using Polychacha to distribute the traffic or to protect the traffic against any kind of intermissions or any kind of spies that could be on the same network or city network as well. And we support basically, we are protocol agnostics. That means that we support basically anything that could travel through the network. As many as you want, right? So the thing is, depending of multiple things. Essentially, the thing that is going to depend more is velocity, right? If you want to do it faster or not, depending on also a distribution of countries, right? Like for example, if I'm living in Mexico and I want to connect to the services that are living in the US, probably a best idea could be having an edge router on Mexico and having an edge router in the US, so the path is going to be close, right? But you may have, like for example, 3 in the US, 2 in Japan, 1 in Brazil, and stuff like that, and create the mesh depending where I'm traveling, and it's going to find the easiest and the closest path to the service. Yes. Yes. Not really. It's the same, quite the same performance degradation you have with VPNs. At the end of the day, VPN is providing you a different layer. It's a secure layer, right? In here, we're providing exactly the same. The big difference is VPN. I mean, don't get me wrong. VPN works, kinda, right? Yeah. Well, if you have a VPN between them, probably not necessarily, right? If you can have it, this kind of tunnel when you have or you want to perform something that's called microsegmentation, right? It's like, okay, we're living on the same network. However, my partner here, Rutherford, doesn't have access to my own computer or shouldn't have access to the database, right? Because he is from marketing. But we are on the same network, on the user's networks. I do have the access. Well, you can create this kind of tunneling as well. So it's like, okay, me as Marcos can access the database. However, Rutherford cannot access the database, right? And we're living on the same network. However, because we're traveling to this tunnel, you are providing this microsegmentation. So you have the ability to use it or kind of not use it, right? Depending on the use case and security you want to approach and other things. Yes, we have the agent for Windows, Mac, Linux, mobile applications, mobile like say my cell phone is Android, iOS as well, etc. Yeah. Excuse me. It's we have the platform is open source completely, right? So you can download. We have actually. Um, yep. You have to give the permission to outbound only, right? And then you create all the policies in here because everything is already connected, right? And that means that you don't open any inbound port on anywhere except on the public routers because they need to listen stuff. But that's it, right? Yeah. Yes, one sec. It's on it. I have to close the. Yeah. Yeah, you can have it all the time open, or you can, like for example, we were discussing some use cases previously. And they were saying, okay, what about if my customer doesn't want to always have the access, right? He wants to shut down the access and only allow me when he wants to. Well, he can do different things. He can, run a script to turn on and turn off the service at the time they need it, and that's it, right? Or they can, open up or create like a link or something, or approve even the petition, the request, etc.
And so, like in the database, what's the IP going to look like when I look at it on the connection inside? It's going to be it's going to be the IP of
The IP you define on the policy, right? Like for example, in my case, I say I want to create to the MariaDB server using the host name Hermes.MariaDB, right? Not an IP, just a name. Obviously, when you're working with RAC, for example, the idea should be using the same name as the exposed database, because otherwise you're going to have issues with the naming, right? But outside that, you can use whatever you want to. And obviously, just one sec. And obviously, you can put all those secure measurements behind the tunnel as well. That means you want to protect, for example, against your own internal users because you don't fully trust them then, which is good. Well, you can put a database firewall in front of your database, right? And still getting protection, but not exposing anything. Yes?
So you need to provision basically the users and get back on that side, on the CT side, and then you still need to provision the users on the database side normally, right?
Yes.
Because you have basically two authentication and authorization
Yes.
methods, right? And then can you map, because you haven't showed this like a mapping on the username inside of the database to
The identity you're providing?
yeah.
You could do that. I'm not sure if you always want to do it. Like, for example, normally in here, what we're trying to do is every single named device, it's an identity, right? So, for example, I have an identity for this one, which is called Apollo, but I have an identity for this one, which is my S22 or whatever it's called, and I have an identity for my own personal PC in my house, on your house, which is called Dragon. So
Right. So in this case, basically, a user on the database need to provide the username and password on the database.
yes, so that means we are only providing the network link, right? So the whatever happens on the database, like it's a database, they need to provide you still the user and the password. That's something they still need to do. Yeah, yeah. It's not a full connection to the database, right? It's just the communication, the link. Yeah. Yes.
This scenario, you have two routers because you want to limit the traffic. That means the first router only talks with the second one. Traffic goes through that link, and then you can access the service, right?
Yes.
And I think you don't use one router because you just want to limit the communication. I mean, you don't expose the second router because you want everything to go through
Yes.
encrypted and
You could provide only one. Yeah.
okay. So let's say that I'm an organization and I have database servers and I want to give you access
Yes.
because you are a partner of mine.
Yes.
I think that the second router will be located within my infrastructure.
Yes.
What about the first one?
Don't worry. So, for example, let's assume that you have your own database and you want to provide me access because I'm going to be your support guy, right? So, basically, you can create your own activity. You can not using this one. I'm going to be this guy in here. Let me write once again. Ben. There we go. So, I'm going to be this guy, right? Let's put an M in here in Marcos. And I'm going to remove this one. Let's assume you only provide this public router, which is the one you are hosting to access to the service. So basically, wherever I live, wherever I move, my computer, my tunnel, is going to communicate with this router, and then from this router, it's going to send whatever it needs, right? You add multiple routers when you want to have, like, for example, if I live in Mexico, could make more sense to have another there to reduce latency, right?
Okay, so if I have, for example, two data centers, I can
That's right. And we have two types of routers, right? So keep in mind that as well. We have the public router, which is whatever you want that they can connect to. And then you have the privates. The privates are those that are going to be like a transit, like the ones that can, only route the traffic based on, which is the less or based on weights, or even for HA, right? Let's assume that you have multiple servers. You probably want to have some HA as well. So basically, that's the other reason to have like this kind of distribution. Yes.
Have you tested transmission rates like with video?
We actually have one customer in Brazil that it's using the solution. They are kind of like in charge of getting the videotapes or video recordings of different stores, right? Like 7-Eleven and stuff like that. So they have this ability to, they put the system in there and they're transmitting all the video to their own cloud.
Is it live or just uploaded transmission?
It is both. Yeah, it is both.
How many seconds, like on the phone you call them and find out how fast it is?
Well, as I can tell you because I haven't, in my case, I haven't like been in this, yeah, I can tell you that, but it is not a big deal because essentially they are doing right now in real time, right? So they're even monitoring the stores in real time, like seeing what is happening right now, and they're not having any issue at all. Yeah, and I think time is up. Yeah, so thank you very much. Just final words. If you want to download the code, you want to start working with it, you want to play with it, you can download directly from our site. And if you can, give us a star just to be more popular on GitHub, right? So thank you very much for your time, and sorry for taking your time.